Okay, today's video is on sums and differences of rational functions. When we're talking about sums, we're talking about addition. When we're talking about differences, we're talking about subtraction. And when we're talking about rational functions, we're still dealing with a function that is comprised of the ratio of one function over another function, let's say m of h. Unfortunately, sums and differences of these functions, we have to think back to our fraction rules. And multiplication and division have nice little rules to them. However, when we're adding fractions, c over d, we have to have common denominators. And so we have to make sure that each denominator has the same thing in it. This one has a b, but it has no d. And this one has a d but no b. So we have to be clever to somehow get a d in here and a b in here. The way we can do that is we can multiply this side by a fancy 1, or d over d, and we can multiply this side by another fancy 1, and we'll call it b over b. If we do the multiplication here, we get ad over bd plus bc over bd. Now that we have beads in the denominator, I can make this addition, which is AD plus BC over BDs. Okay, so again, we have to have the same thing in the denominator before we can do an addition or a subtraction. I'm not going to do an example with real numbers. I'm going to hop right into what we might see for homework. 6. There's two ways to do this problem. You can either factor and cancel, or you can just do the multiplication trick. So I'll do this both ways, and you guys can see. I like to factor as much as I can before I start any problem. So on this side, I can't factor anything, but on this side, however, I could pull a 2 out of the top and say this is 2x minus 4 divided by, and I can turn 6 into a fancy multiplication, call it 2 times 3. And I can get rid of these 2's. So really I'm looking at the subtraction of 2x minus 1 over 3 minus 2x minus 4 over 3. This was cool. Without doing our trick that I just showed you with the BDs, or the beads, I was able to get the same denominator. So now I can do my subtraction. What we have to be careful about when we do the subtractions is we have to be aware of what we're doing with our parentheses. So if we have 2 minus 1 minus, this minus is subtracting this entire thing. So we have to put parentheses here. 2x minus 4. And this is all over 3. What these parentheses help tell us is that we have to distribute this negative to both pieces. So what we're really looking at is 2x minus 1 minus 2x plus 4 all over 3. This will continue to wrap up. Now we can get rid of these. Negative 1 plus 4 is actually 3 over 3, which just equals 1. Cool, that wrapped up very nicely. Let's go back and do the same problem again, but let's not do the factoring and see what happens. Okay, so with our clever version of 1, 2 over 2, when we multiply this in, we get 4x minus 2 over 3 minus 4x minus 8 over 6. I'm sorry, this is over 6 now. Over 6. Now that we have the same denominator, we can do our subtraction. So this equals 4x minus 2 minus, and again, we got to be careful with the parentheses. We're subtracting the entire thing. 4x minus 8 all over 6. Again, these parentheses are helping us tell us that we need to distribute the negative. So now we have 4x minus 2 minus 4x plus 8 all over 6. This will give us 6 over 6, which equals 1. That's good. We got the same answer. Well, we should have, because we did it already. Let's try another one. Okay, let's try this critter out. This one's a little more difficult. What I recommend doing is factoring whenever you can factor. So we have to recognize this as a difference of squares. So this is really 3a being squared minus 2b being squared. So we can change our denominator to look like 3a over 3a plus 2b times 3a minus 2b minus 1 over 3a plus 2b. This is cool. This helped us out. Now we can notice that this fraction over here is missing a 3a minus 2b. So if we're clever, we can add it to this denominator. So what we'll do is we'll multiply by a fancy, clever version of 1. We'll call this version of 1 3a minus 2b divided by 3a minus 2b. When we do these multiplications, I only recommend multiplying the numerator, which is going to be easy this time. Leave the denominator inside of the factored version, okay? Leave it like this. So when I rewrite this, this is going to be 3a over 3a plus 2b times 3a minus 2b minus, I'm doing this multiplication, so I'm going to get minus 3a minus 2b all over 3a plus 2b times 3a minus 2b. I have the same denominators now, so I can continue and actually do the subtraction. The way this is going to be working is it's going to say 3a minus, again, we got to place our parentheses in here, 3a minus 2b all over the fraction of 3a plus 2b times 3a minus 2b. Again, these parentheses are here to help us tell us that we need to distribute this negative. So now we're looking at the fraction of 3a minus 3a plus 2b all over our 3a plus 2b times 3a minus 2b. The reason we want to leave these inside of the factored form is sometimes in the numerator we'll get one of these factors back and we can continue to cancel stuff out. So there's no point in putting this back together just to take it back apart. So we'll leave it apart. Only in the numerator do you need to be doing the multiplications. Let's clean this up a little bit. We have 3a minus 3a, so these are actually going to cancel. And it looks like we're left with a final answer of 2b over 3a plus 2b times 3a minus 2b. Again, these take a little bit of time, but I find these a little more fun since you're looking for things to get rid of. I like throwing things away, so let's throw as much away as we can, clean up the problem, simplify to what we can. If you guys have any questions or comments, please let me know via email. I'll see you all tomorrow.